So hello everyone. Welcome you all to Intellipaat's live webinar on understanding important data structure for MAANG interviews. So today's webinar will be conducted by Mr. Aditya Dua, who is a senior consulting engineer at MongoDB. He has more than 10 years of experience in the field of web and mobile application development, and I am pretty sure he has a lot of wisdom to share. So without any further delay, let's welcome Mr. Aditya into the session. Sir, over to you.
So now all of you welcome and thank you for taking out time. And I'm Aditya. So thanks for that warm introduction by all of you. Now, when it comes to understandings of data structures and an algorithm, it's a dark web, and like we have found that all of us are under this impression that we know data structures, but somehow we are not able to prepare ourselves for the next level of interview preparation, which is why we need to understand the roadmap, the basics, and the structure which is needed to clear these interviews. So without wasting time and without further ado, I'll just get started with the webinar. Now, what all we will be covering in this webinar, again, I will be covering essentially the overview of structure, how this webinar should look like, how your preparation should look like, what all programming languages you have options for, which one can you choose, which programming language makes it easier for you, and all of that stuff. Then we will be moving on to how do you judge an algorithm. So like complexity, how you can make your approaches better, and then will be the algorithms that we have to master or we should be have understanding of. And we'll be ending it with some tips and tricks which I feel are important in order to ace these interviews. That's about me. Now, the very first step and the most important step, I'll just pause over here and I'll continue from here. Now, the very first step when it comes to acing an interview on data structures, the very first step that you have to follow is you need to have a thorough understanding. Now, the first thing is you have to choose a language which makes sense. Now, this is very important. Why this is important? Because this is the language where you will be writing your codes in, right? So like again, I have seen people choosing Java, C++, Node, or JavaScript in short, and Python. Again, I'm not biased with any language. You can go with any language, but the language you choose should be your home ground. So what I mean by home ground, you should have a complete understanding of the language in terms of the structure, the approach, and how you work on that language. Now, you have to understand that the language you choose, you should be comfortable and clear with it. Now, any reasons? Okay, if you guys are choosing language, like will you be going with Python? Okay. So yeah. So now, okay. Again, I come from a different background. I come from Java background, but that should be okay. Now, when you are choosing a language, what should be the approach you have? So, like, let's say I have chosen Java or Python. So when you choose any language, typically all these languages today are OOPS oriented. So it is important that you understand the concept of OOPS. That's one, right? Then what is more important for you is, what all support it has or what are the collections available. Like again, I'm from Java background. In Java, we have collections, which is like array list, then maps and stuff like that. In Python, we have something like a dictionary, a set. So what I want you to understand when you choose this is understand the internal working of these. So it's not that you have chosen a language and the work is done. No, you have to dive deep and understand the working. So if a map is there, how does a map works? Now, once you have chosen these steps, then again, the third step is not typical important for you, but I have personally, I personally like it. What I do is I read around the implementation of that language. Now, what do you mean by implementation and what is the purpose of implementation? For example, in Java, in collections, I have a sort of framework. So I can use collections.sort. right? Again, each language will have its own way. Python has a mechanism to sort stuff, right? Guys, yes or no? So when you have that mechanism, how does that looks like? So like, for example, if I'm in Java, this is a source code. I will read this code. How is this code implemented? So, like here I'm supposed to read and understand every aspect of the program. So like if this is system, why is it final? If it's out, what is the type? What is these? Is it static in nature or what? So gather these pointers to understand the ability to write an efficient code, or to this will help you read properly written code. Does it make sense, everyone? Again, this step is not a mandatory step, but by going through this step, you can ensure that you are uh, you are in the right direction to read the other code properly. Why? Because many a times, like in the interviews, you may be asked to review a code. So when you are reviewing a code, you have to understand the design principles and understand the pattern which is to be followed. So till now, what is final is just my language has been finalized. Let's say that for the sake of simplicity, we are either going with Python or we are going with Java. Now, once this is good, now again you have to understand the role of data structures in your everyday life. I know it sounds a bit too real world or a bit too too good to be true, but again, understand this. Where are you using your DSA? For example, I know all of you are having a smartphone, right? Now, when you guys have a smartphone, and when you are looking in the contacts app, or when you are looking in your WhatsApp app, right? You are able to scroll down. So, like in contacts, you can scroll down using A, B, C, D. So if I go to D, I see all the contacts with D. What kind of algorithm is this? Does it make sense, guys? Now, if typically nowadays, if you have around 1,000 contacts on your phone, and you are able to land on a contact with D in a few milli or microseconds. So how does that work? This is the implementation, or a, I know, like it sounds very, very, very awkward, but yes, that's the truth. And you have to get through this. This is what will make you have understanding of like how the data structures are written, and how do you write a efficient data structure. So now this efficiency in 1,000 contacts, I'm able to reach a contact with D in a few milliseconds or microseconds. What is this known as? This is known as efficiency of my algorithm. Have you heard of something like notations? How many of you understand notations? Big O of n, yes. Big O of 1, big O of n square, big O of n log n. So what are these? These are known as time complexity of an algorithm. So now when you are reading this or when you're writing this, this is how you measure the time efficiency of your algorithm. So now, before you jump on and before you like start reading the algorithms, you have to understand all these things. Correct, guys? Now, notations are typically of three types. So big O is one. Then big O is something like this. Then we have omega. So now, what is big O? It defines the worst case complexity of my algorithm. Correct, guys? Omega describes the best case. And theta, which is something like this, this defines the average case complexity. Sorry. Does it make sense? Now, before you jump on, you have to judge, you have to see how will you judge a code written in big O, omega, and theta. So Now, if you see big O of n, big O of n square, we even have big O of 2 to the power n, and this is another big O of log n also. So you have to understand how does a n square differs from a n log n. That's how you will be able to write a efficient code. Now, once you're done, once you're done with the space complexity, once you're done with time complexity, you have to judge your application or your code on space complexity. So, what do you mean by a space complexity? So, space complexity is defined as typically the extra space required for the application to or for the algorithm to run. So, what is space? The extra space which is required. So if you remember a very basic example, we had an example of where we were doing swap two numbers using third variable. So when I use a third variable, so what is my complexity or what is my space complexity? My space complexity is bigger of 1. Why? Because I need 1 unit of extra space. Now, this is all what is required till now. So till now, I'll just repeat whatever I've discussed. The first step is which is required is finalize a language of your choice. Once you're done with the language, understand the working or the internal implementation of language. Once done, understand the complexity, which is a function of time and space. You know the basic data structures. I'll give you a good exercise. So now imagine this is my browser, right? If I go to a website, let's say example.com, right? And from example.com, or okay, this is not having anything. Let's go to amazon.com, right? From amazon.com, I click on a product like maybe like this, video games. From video games, I go to this meta one, and then I go to this part, right? Now, if I keep on pressing back, I am able to land onto the home page or the first page. If you were implementing this back functionality, which data structure would it be? If you understand, I am maintaining, is it an array? Think out loud. Why? Because I visit site 1, page 1. I go to page 2. I go to page 3. I go to page 4. And if user presses back, I go to page 3, then page 2 and page 1. I'm always following the same order. There is no, no random accesses. So will this be an array or will this be a stack? So I go to page 1, I go to page 2, I go to page 3, I get to page 4. So whenever I visit a site, I push that page, and when I press back, and this concept is known as LIFO, last in, first out. So, like now you all use browsers on a daily basis, right? So that is how you will learn and understand the working of the structures. So this is how I was talking. So will this be an idle one or this? This is an idle one. Hence, we can say the browser maintains your history as a stack. Now comes the understanding of different types of data structures. What are the main different types of data structures? Again, this is the first part of the DS. Or till now, we were just preparing the base for DS. Now we are actually getting started with the DS. What will be the different types of data structures? Yes, string can be still one of them, I would say, but not others. List, exactly. Good, guys, that's good. So typically we have two broad categories. The first one is known as a linear data structure, and another one is known as a non-linear data structure. Now, what do you mean by a linear data structure, guys? A linear data structure is a one which occupies a linear space. For example, an array, a string, and linked list, stack, and a queue. Does it make sense? These are the basic data structures which you should be comfortable with. Now, once you're done with this, it is your time to move beyond these and cover the non-linear data structures like trees and graphs and heaps. So now, if this part is clear, then we move on. So now I hope you are understanding the sequence of stuff. So what is the sequence? What is the first step? What is the second step? And then comes the third step. Yes. The first step is having a mastery over language. What is the second step? The next step is understanding of complexity. Good. And the last and the final, I would say not the final, but the third step would be to understand the working and the syntax and the idea behind different types of data structure. Now, once this is clear, it is our time to move to the next and the final part, which is learning and understanding algorithms. By learning, I'm not asking you to mug up the algorithms. No, it's not that. What I mean to say over here is you should understand the different types of algorithm, their use cases, the purpose in which you can fit them along with other stuff. When it comes to algorithm, there are different types of algorithm. The first type of algorithm are known as sorting algorithms. This is our starting point to working with or to working with DSA. So we got, so DSA is combination of data structures and algorithm. DS I have already discussed. A is what is this part? Correct, guys? Now, on sorting, it's important you understand the bubble sort. Then you understand the selection sort. Then there is insertion, merge, quick, heap, and so on henceforth. Correct, guys? Now, with these ones, you have to combine these algorithms with their complexity. So, like if it's yes, heap is another one. So, if it comes to bubble, what is the space complexity and what is the time complexity? Now, once you're done with these sorting, then you have to move on to the next part, which is searching. For all those who are between 0 to 2 years, searching will be one of the questions which you will be asked upon. Now here we have two types of searching, linear and binary, right? Now again, you have to now understand, now you have to implement them, and then you have to, now once you're done with this, then what you will do is, I will be clearing the stuff now. Now, once you are done with sorting and searching, it is your time to hit the ground. Now, how do you hit the ground? So you can go to any coding framework or any app or any platform you are comfortable with, HackerRank, whatever is it. The names are different, the logic and the questions are still same, and start taking questions on arrays and strings. So typically, the first round of your interviews will be limited to these basic questions. Now, once you're done with this, then you have to go on. Okay, sure. So what I'm saying is, see, once you are done with sorting, once you're done with sorting and searching, So, like once you've implemented these algorithms, they are most optimized, your code is good, then you have to start practicing DS questions or DSA questions from platforms. Now, which kind of questions will you target? You will target questions on arrays and questions on strings, because major questions on arrays are like this. So, okay, like for example, in an array, find which element is repeated how many times. Does it make sense? Try working on these basic questions. So once your sorting, searching, both are done, it's your time to hit the ground with some advanced algorithms. So what are these? One of the algorithm is recursion. So recursion is a program. Okay. So what is a recursion? It's a technique of writing a function which calls itself over and over again. Correct, guys? Now, once you're done with this, it's your time. So you're like now recursion. So you now understand recursion, do some questions on recursion, practice recursion, and then so right now you're just understanding the different kinds of algorithms and not their implementation. Then you have to move on to backtracking. So what is backtracking? Again, it's recursion with some additional conditions. Now, if you want to understand, a very basic example of recursion can be factorial, which you have done using recursion. Again, I'm not giving you the problems to solve. I'm just talking around the algorithms to make it work. Correct, guys? So, like in backtracking, like let's say you are solving a Sudoku, then that's a backtracking problem. You are trying a combination of shares and their and maximum profit. So now what next? We now move on to other algorithms, which is greedy approach. So when you are covering greedy approach, it's a program in which the common example is knapsack problem. Now, the algorithms being implemented with greedy are multiple, but you have to first understand this, then try on some questions based on this approach. Then the last and the most difficult part is what I call DP, which is dynamic programming. Now, if you are clear till here, it means, or if you have done till here, it means you should be confident about the basics, you should be confident about the stuff, and you should be confident of the like of the concepts which are used in DSA. And once you are clear, then it comes greedy approach. I'll explain what it means. So greedy approach is, like understand it like this. So, when you are working on any algorithm, right? So how do I wait? What? Let me see if I can actually, like you are not aware about the national problem, otherwise that would have made much sense for you. Okay. So the idea is what you do. You take one part and then you and okay, let me take it like this. Okay, so what you do is, like let's say you have to solve a problem in which yes, okay. Let's say that I have some coins, or I have some I have some okay, yes, I have coins of the value 1, 2, and 5. I want to make 100 rupees from them. And of one, I have 50 coins, 20 of this one, and 15 of this one. How will I do it? Now, when I do this, I have to make sure that I have either the minimum number of coins or I have the maximum number of coins. So when we are solving such problems, and so what we do, we basically try to, we go step by step. So like first approach will be take all from here and then add remaining ones over here. So what it means, it first solves the problem, then moves on to the next part and to the next part in a way that knowing that the next part will always be more optimized or more performant, and hence it that's how it actually chooses the one which is most fit or which is the global solution. Okay, now once this is done, then our next part is on dynamic programming. Again, dynamic programming is recursion with some memory. So in recursion, typically we don't take extra objects, but in dynamic programming, we take that, and that's how we write dynamic programming approaches. Now, once you are done with all this, then you just have to follow one approach, or which I call as master one, which is practice and practice and practice. So how do you approach this practice, or how do you approach that? So basically, this is what I can say as tips and tricks. Now, first of all, try working on one problem each day. So I'm not saying, okay, now, I'm not saying to solve one problem each day. Let's say target that in 1 week, I have to complete at least 3 problems. So on week, this is day one, then I have day two, day three, and day four, day five, day six, day seven. You start a problem, and if you reach solution, perfect, right? It's done. So if now you have reached the solution, then on the next day, try optimizing it. So how you can optimize? Either by bringing down the time or space complexity. And if in case you are not able to do it, then continue the solution. So there are two cases. You start a problem. If it is solved, you optimize. Otherwise, you continue solving and you optimize on day three. Correct? But what is the central approach? The central approach is you have to spend 1 hour to 2 hours on optimizing each day, on optimizing each problem. Sorry, not per day, it's per problem. Why do we need that? We need this in order to ensure that our solutions are reaching the best approach. Now, once you have been able to, once the first you did a problem, you took a problem, you solved a problem, and then you were able to optimize the problem. And then comes the last part of dry running the problem or dry running the solution. Now, why this dry running is important? Because it will come handy for edge cases in your interview. Because when you are running on an interview, typically, we don't have, you sometimes you may be working on, on a simple exercise, or you may be working on a simple editor. In that case, dry running really helps. So the approach you have to follow: problem, work on the problem for 2 to 3 days till it's solved. If it's not solved, leave it. Go to the next problem. Don't spend your time being stuck on one problem. Then once solved, try optimizing it. And once optimized, try to dry run the solution so that you can find out if there were any edge cases which were left out. So now I'll just quickly run you through these slides, guys, to see that what we have covered. So the first part of the slides was to go to the programming language which you are comfortable with. Then you have to understand the complexities. Then you have to understand the data structures which are linear and non-linear. Then you have to understand the algorithms. So the sorting algorithms, the searching algorithms, and the other or the advanced algorithms. Correct. Then comes the pro tip, which is, whenever you are working on a solution, spend just 1 hour to fix it. If not, then leave it, right? And once you're done with this, it's your now time that you go ahead and you try it some other day, or you leave it. If not, then maybe you can take some help or some stuff, maybe your friends, your editorials, or your YouTube channels, to find any help on that, right? And once done is, you have to ensure that you always check on the logic which was used. because this is the logic which you can optimize every now and then. And once this is done, once you are able to reach the solution, it is now your time to dry run the. Then I think that was all from my side for this session. Opening, I would like to thank you all for your time, and I would like to pass it on to the team, which who can take it from there.
Okay, so thank you, sir, for providing such informational and a wonderful session among our learners, and we are always be thankful for your presence. Thank you. Thank you, guys.